Hello, parents, guardians, students, everybody out there. We're going to work on some fraction problems that we're working on. We got a test coming up. So what we're going to do is we're going to multiply a whole number. In this case, I'll make it a 5. 5 times 3 fifths. Okay? Multiply this whole number, the big number, times the numerator, top number. That's going to give me 15. I just keep my denominator. Denominator is going to stay the same. That's going to be a 5. That's an improper greater than 1 fraction. Us older people, more mature. Guy's a 5. Looks like an S. You just call it improper. They call it greater than 1 now, because it is greater than 1. So this isn't the total answer because it may not be the one that they want for the test or for the exams or whatever. So how many times does 5 go into 15? Real quick. 3 whole times. Focus. Okay. So 5 times 3 fifths is 3 or 15 over 5. So it would be 3 or 15 over 5. A couple errors they have. They'll try and make this some uh, mixed number. They'll try and add a fraction to this. You can't do it. It's just a fraction. It's just a whole number, not a fraction. We're going to work on one in a second here that has a fraction. So students know this, and parents, guardians let the students know. If this goes in here evenly, 5 times 3 is 15. Nothing left over, 0. So my answer would be 3 or 15 over 5. So let's work on one that does have a fraction or a mixed number, or yeah, fraction, mixed number. So let's say, let's keep it even easy. That's another thing they got to work on, multiplication. Students, you know you do. Times 6 over, I got to make sure I know, 7. Okay. So I do the same thing. Whole number, big number, gives me 30 over 7. Now, how many times does 30 go into 7? Students may not know their times tables. Students, you may not know your times tables. What do I tell you to do? Start adding. It'll learn that way. 7 plus 7 is 14. 14, 15, 16, 17, 18, 19, 20, 21. Still not there yet. 20, let's see, 7 plus 1 is 28. 28 plus 7 is 35. Oh, too much. Sorry about that. It's too much. Oh, get my camera here to move. Okay. So 7 times 1, 7 times 2, 7 times 3, 7 times 4, and then 35 is down there off the screen. Sorry. Okay. So it's going to go in there 4 times. 7 times 4 is 28. So going back to my problem, 4 doesn't go into 3, goes into 30. So excuse me, 7 doesn't go into 3. So 0. It does go into 34 times. 4 times is 28. We said that. That 2 becomes my remainder. So I'll have 4 whole numbers, write it kind of big. That's my whole number. And 2 over what number? 7. So let's go over that again. 5 times 6, 7 is 5 whole number times 6 is 30. Keep my denominator. That's a correct answer, but we need to convert it, change it to either a whole number, mixed number, so it's not greater than 1, because it might not be that on the test, or they may say which is all that apply, select all that apply. So 7 into 30, 7 into 3, no. 7 into 30 four times. 4 times 7 is 28. I subtract. I get 2. 2 goes here. Keep my 4 as my whole number. Write it bigger. Some students have an issue with writing it kind of small, so they may get confused. And then the 7 here stays the remainder there. Sorry. So that's how to do, and it doesn't matter which way it goes. If it goes the other way, it's the same thing. If it was opposite of that, I'll show you same way, like what I'm trying to say is 6 times 7 times 5. Focus. There you go. And we just do the same thing, but this way. So 7 would stay the same, and I get 30, and then the division. So it doesn't matter which way it is. Multiplication is commutative. Okay. Doesn't matter which way it goes. Okay. Now we're going to do one that's a little bit harder, trickier for students. But that division, parents, guardians, make sure students work on their division. That's the biggest problem they have. So say my number just as an answer would be 42 and 5. I mean, even the 5 times tables I've noticed some students struggling with. Um, Going back to, I'm trying to remember, Schoolhouse Rock, an old thing on YouTube. We'll teach you your times tables. Great video, Schoolhouse Rock. Check it out. 5 times what gives me 42? Skip count. 5, 10, 15, 20, 25, 30, 35, 40, 45. Okay, so 9's too much. So it's 8. 5 can't go to 4. 8 times 5 is 40. Subtract my whole number. I mean, I could write 8, but 8, but just let's say it's 8. 2. My 2 becomes my new numerator. And this, the 5, is going to stay my denominator. So, and here's how to do it backwards to check to make sure this is this. Glad I shot that. So we have 825. What I'm going to do is I'm going to go backwards. I do that. I try and help my students remember to do this going backwards. Okay. So I divide it first. So I'm going to multiply. 5 times 8 is what? We said it here, 40. Plus the 2, because I subtracted, plus the 2 gives me 42, and I keep my denominator. So 42 over 5, 42 fifth, 42 fifth. So those are the ones for multiplying fractions. Subtracting, here's one of the issues. Subtracting and adding are simple, okay? For us right now, it's a common denominator. It's common. So it's just 5 over 6 plus 2 over 6, okay? Keep my denominator. Stays the same. 5 and plus 2 is 7. Greater than 1, improper. I have to divide again. 1. 6 goes into 7 one time. 1 times 6 is 6. Subtract 1. Numerator, denominator stays the same. Okay. 6 times 1 is 6, plus 1 is 7 over 6. So I am correct. Here's with mixed numbers, a whole number and a fraction. So adding them is easy. Just add them straight across. Subtracting may be an issue when it comes to this. So if I have 5 and 1/2 minus 2 and let's see. I got to keep my denominators um, the same in this instance. Sorry about that. I gave a problem. It would be even harder. We're not even covering. So 5 3/5 minus 1 4/5. Okay. 5 minus 1, 4. That's not the problem. Problem is up here. 3 minus 4. Well, don't make the mistake, students, of going 4 minus 3. Not that written that way. Yeah, it's not written that way. I'm going to say whole numbers. I can do it, but I have to borrow. I have to regroup my number. So I go to my friend here, my big friend who's got the money. I can borrow from him, get it from him, regroup from him, make change. I need a fraction. Since I can add common denominators with like, add fractions with like denominators, I can just make this the same one. Because we all know that 5 over 5 is 1. I borrowed it, so now it's less, regrouped it. So that 5 becomes a 4. So that number is this number. That's a 1. Sorry. 1 plus 4 is 5. So then I'm going to add that to what? I still have 3/5. I didn't change that. I changed a fifth. I'll figure it out. Fifth. Okay. I changed this. I didn't change this. So that stays the same. So 5 plus 3 is 8. Running out of room here. 5 plus 3 is 8 over 5. And I had my 4. Okay. So I can now have 4 and 8/5, which is my new number. I borrowed, regrouped from here, became 4 5/5s because I want to keep my denominator. That's 1, whatever it is. If it's 6, it would be 6 6 7 7 7 20 20 20 20 over 20. Okay. So here I have this is this. Greater than 1, improper, would be this number. So now I can subtract 1 and 4/5. Well, let's do this. 8 minus 4 is 4. 5 stays the same. Okay. 4 minus 1 is 3. So let's go over that problem again, break it down. We can't subtract 4 from 3. My denominators are going to stay the same at this point because they're like. They're like denominators. This 5 becomes a 4. 5 5. So this is this number. 1 plus 4 is 5. I keep my 3/5 and add them together. That's a 4. So 4, 8, 5. Keep my denominator the same. Now I just make this number this number. 4 and 8/5 minus my original number. 8 minus 4 is 4. 5 stays the same. 4 minus 1 is 3. Sorry about that. Keep forgetting to show the screen. Okay. So let's go one more time, and I will call it a wrap for this. So if I go, let's make it 5, doesn't matter. Okay. And for 8 minus 2 and 5/8. Okay. So can't subtract 5 from 4. I got to get from him, my friend, my big friend here. He's bigger, got more to lend. Okay. 5 becomes a 4. Break it down. So what's my fraction going to be? 8/8 plus 8/8 plus 4/8. Because that didn't change, remember. Okay, I'm not changing this, I'm changing this. okay? This has changed here. This is not. So now I add them up. 4, 4 plus 8 plus 4 is 12 over 8. I write that down here. 4 and 12 eighths minus 2 and 5 eighths. 2 and 5 eighths. I'm going to run out of room here on this board. Okay? So I'm going to write it over here. Okay? Actually, 12 minus 5. Well, students are still, believe it or not, having a problem subtracting. Count up from 5 to 12. 5 to 12. 6, 7, 8, 9, 10, 11, 12. What's my number? 7. 7 eighths. That's a 7. 4 minus 2 is 2. So that's my answer. 2 and 7 eighths. Going back, break the 4 down because I have to. If this was a regular number, if this was a 6, I could subtract. If it was 6 eighths, I could subtract. But I can't do it this way. Common mistake from students, subtracting 4 from 5. Not it. Okay. Denominator stays the same. So I'm going to break it down. 4, because I want to borrow from here, regroup, becomes a 1. They don't like to say borrowing anymore because you're not going to give it back. So you'll hear me say that a couple times. Borrowing, regrouping. So we used to say borrowing, but you don't give it back. The new math says, well, doesn't really matter. Borrowing, regrouping. So this becomes stays 4. I add them up, add them up. This becomes my new number to subtract from. So 4, 12 eighths, 12 eighths, yes. Okay, subtract 12 from 5, 5 from 12, 7, 8 stays the same. 4 minus 2 is 2. And that's it. Work on those, practice those, show your students some of those problems, work with them on those problems, and they'll do great on the test and do great on these future assignments that they need. Practice that multiplication, and I'll talk to you next time. Bye.